Hello, good morning everyone. Today we are going to start our first chapter of class 8, that is rational numbers. So before starting rational numbers, we will discuss some number systems in which our first number system is natural numbers. Natural number is denoted by capital letter N. It's nothing, it's just your counting. Natural numbers contains counting from 1, 2, 3 and so on. So our natural number is 1, 2, 3 and so on counting. Our next system is integers, whole number. Whole number is denoted by capital letter W. Whole number is a number system which contains counting from 0. 0, 1, 2, 3, so on. So whenever someone asks you what is natural number, so you will tell a set of counting, that is 1, 2, 3 is known as natural number system. Whole number is 0, 1, 2, 3, that system is known as whole number. Okay. Our next system is integers. Integers are represented by capital letter Z, and what integers contain? It contains counting with positive side as well as negative side, -1, -2, -3. So what is integers? Integers are system which contains 0, 1, 2, 3, 4 as well as their negative numbers, that is -1, -2, -3. I thought all of these systems are clear to you. That natural system contains counting from 1 to 1. Whole number system contains counting with 0, and integers this 0, 1, 2, 3 and -1, -2, -3. So the next thing is our rational number, which is the important and our topic, rational numbers. Rational numbers are represented by capital letter Q. And what is definition? What is this? Number in the form of P by Q, where P and Q are co-prime integers. Co-prime integers, and Q shouldn't be equal to 0. So one thing is this denominator Q, it cannot be 0, and another thing is this P and Q are integers. And which type of integers are these? Co-prime integers. Also you can remove this co-prime. Okay, this is also right, that PQ are integers. Do not get confused with co-prime. P and Q are integers and Q shouldn't be 0. Let's understand it by taking some examples. First example, like 2 by 3. So how I am going to check it? Is it a rational number or not? So first thing, it should be in the form of P over Q. Look, 2 by 3, it is appearing like P by Q. Yes, it's P by Q. Second thing, P and Q should be integers. So 2, yes, we have read it that any positive numbers, positive counting or negative counting is integer. So 2 is integer, 3 is integer. Second condition is fulfilled. Now third thing, this 3, it's not 0, so Q is not 0. So it's a rational number. Another example like -5 by 4. So first thing, what we have to check, is it in the form of P by Q? Yes. P over Q. It is in the form of P over Q. Next thing, P and Q should be integers. So 4 is integer, yes. 5, yes, we have studied it. -1, -2, -3, these are integers. So -5 is also integer. So this is fulfilled. P over Q, PQ integers. And last thing, Q shouldn't be 0. Check. It's 4. 4 is not 0, so it is a rational number. Now look for this. Only 2 Is it a rational number? Yes, it's also a rational number because 2 can be written as 2 over 1. Any integer, we can write every integer like 2 by 1. And if it is 3, so I can write 3 over 1. So if someone gives you simply an integer, you can put 1 as a denominator to make it a rational number. Now check it. P by Q, first condition fulfilled. P, Q are integers. Yes, 2 and 1 are integers. Q not equal to 0, so it is a rational number. 3 is also a rational number. Same way, okay, calculate for 0. Is 0 a rational number? Same way, 0 can be written as 0 by 1. Also, we can write 0 by 2 or 0 by 3, anything. 0 can be written in any form, 0 by 1, 0 by 2, 0 by 3. But the conditions are, is it in the P by Q? Yes, it is in P by Q form. Second thing, P and Q are integer. 0 is an integer. 1 is also integer. This condition, Q not equal to 0, is only for the denominator. Here 1 is not equal to 0. So we can say that 0 is a rational number. Okay. So any system now which contains these kind of number is known as a rational number system, and this is known as rational numbers. Hopefully it's clear to you what is rational number. So definition, P by Q form number, and do not forget this, PQ should be integers and Q shouldn't be 0. That are known as rational numbers. Okay, let's come to its some properties. Rational numbers, first property, or general we are talking about some properties. Our first property is closure property. It is going to be a bit difficult, closure property, to understand you what is closure property, but if you will try to understand with me, it will be easy for you. We will start it by an example. What is closure property? So firstly, whenever we talks about closure property, it comes with an operation. It comes with an operation. So now what is operation? You might be thinking where I am going in bio, operation and all things. So what is operation? In maths, operation means addition, subtraction, your multiplication and division. It can be something else, but for you in maths, operation means addition, subtraction, multiplication or division. So whenever we talks about closure property, we will always say like this: closure property over addition, closure property over subtraction, closure property over multiplication or closure property over division. We cannot say simply what is closure property. With closure property there is need of operation. So let's talk about with addition operation. So our topic will become like this: closure property over for addition, and over which number system? Over natural numbers. Let's start with over natural numbers. So both things should be defined. That closure property, it is over addition, and with on which set you are doing it: over natural number, over rational number, over integers. So how it goes, like if we are talking about closure property over natural number, so first of all we will take any two natural number, suppose 2 and 3. Okay, now if we are talking about addition, so what will I do? I will add them. 2 plus 3, so answer will be 5, and 5 is also a natural number. So what is it? Set is said to be fulfilled, said to be closure over addition for any two number belongs to that set. Here a set is anything that is rational number, integers, natural number. Okay, set can be anything that is rational number, integer, natural number. So a set is said to be closure, said to be holding closure property, over addition if for any two numbers belongs to set. Let it be A and B. Okay, let it be A and B. So if A plus B also belongs to same set, now understand from example again. Like if we are talking about closure property for addition over natural numbers. So if I take any two natural number, again if I take any two natural number like A and B, if their sum A plus B is also belongs to natural number, if it is also natural number, then I will say closure property holds for natural number over addition. Clear? Okay. Again, let's start. Closure property over integer. Closure property for integers for natural number over subtraction. Or you can say closure property for subtraction over natural number. Look. Now what we have to check closure property over natural number. So our first step will take any two natural numbers A and B. Let A comma B are our natural numbers. Clear? So whenever they says you closure property for subtraction over natural number, first step we will take A and B, any two natural number. Next thing, we have to go for subtraction. So we will do subtraction of that numbers, A minus B. So now think, if A and B are any natural number, so their subtraction will be a natural number or not? Think. Will A minus B will be a natural number or not? You can take some example like 2, 3. These are natural numbers? Yes, it is. Now 2 minus 3, what will be it? Plus minus, so it will be minus 1. And minus 1 do not belongs to natural number. Okay. So 1 do not belongs to natural number. That means one do not belongs to natural number. That means there are two natural numbers over which 2 minus 3 is not going to again in natural number. That means A minus B is not necessary it will be a natural number. A minus B is not necessarily a natural number. So we will say closure property do not hold for subtraction over natural numbers. So closure property is not applicable or do not hold for subtraction over natural numbers. Clear? let's talk about closure property for multiplication over natural numbers. How we have to start closure property, checking of closure property? First thing, we are taking a set natural number, so we'll take any two numbers of natural number, a comma b. Let a comma b be any two natural numbers. Okay. Second thing, firstly take any two number. Now we are talking about multiplication. So start checking for their multiplication. A multiply b. Now tell me guys, if we multiply any two natural number, what will be its result? It will be a natural number or not? You can take any example like 2 into 3, 6, 3 into 5, 15, 1 into 4, 4. So all the multiplication going in natural number. So a multiply b equal to ab, it is going to is a natural number. So it is a natural number, so we can say that closure property holds over multiplication. We can say that closure property holds. Clear? How are we going? Closure property for multiplication. First thing, we have to take two numbers, natural numbers, any two natural number, a, b, b, any two natural number. So next step, we have to do multiplication. So we'll do their multiplication. A multiply b, a, b. So we have to check it now. Will multiplication of two number is again a natural number or not? Yes, a, b will be a natural number. So we can say that closure property holds for natural number over multiplication. Now next our fourth operation, division. Closure property for division. Okay, again natural number. So we'll start, let a and b be any two natural number. Okay, a and b be any natural number. Now what we have to do? Division. So we'll divide them. A divided by b. That is a by b. Now think, do a by b comes in natural number? Like if a is 2, b is 3. So 2 by 3. Is it a natural number? No. It's not a natural number. That means a by b is not a natural number. Not a natural number. So closure property do not hold. Closure property do not holds over addition, over division for natural numbers. Clear बच्चे? Okay, next. Same way, we will talk about closure property as we have talked about natural number here. For all the operations, multiplication, addition, subtraction, division and addition. So again we are going to discuss closure property with same operations, addition, subtraction, multiplication and division, but over another set. That is our next step, which was whole number. No, whole number will be a homework. We will talk about with over integers. So again, we are talking about closure property. So first thing which should be clear to you, what is integer? I'm writing here. What was integer? Or counting. 1, 2, 3, so on, and this side 0, -1, -2, all things. These numbers was our integer. So how we will check closure property for integers over addition? Firstly, recognize your set. It's a integer. So what will we have to do? Take any, let A and B be any two integers. Any two integers. Okay. So we have taken A and B be any two integers. Now look for your operation, that is our addition. So what we are going to do? A plus B. Okay, so we have done A plus B. Now what we have to think, is A plus B is a integer or not? Now check here. 0 plus 1, 0. 0 plus 1 is 1, which is a integer. 0 plus 2, 2, again integer. 0 plus 3, 3, again integer. 1, 2, 3. 1 plus 3, 4, integer. Minus 1 plus 0, minus 1, which is integer. Minus 2 plus 1, that is minus 1, which is integer. So A, B, if A, B are integers, then their addition is also a integer. So integer. That means closure property holds over addition. Closure property holds over addition. Clear? Okay. So what again? Now closure property for integer over subtraction. Okay. Closure property for integer over subtraction. Again repeating. First step is count your or check your set. Our set is integer. So from where I will start? By taking two integer. Let A and B be any two integer. Now second step is look for operation. Subtraction. So what we have to do? A minus B. Now we have to think A minus B. Will it be an integer or not? Now if I subtract any two integers like 1 minus 2 minus 1, 1 minus 3 minus 2, 2 minus 3 minus 1, or anything, if we will subtract any two integers, answer will be a integer. So we can say A minus B is also a integer. So closure property holds. I told you that it will be a difficult thing for you for the starters. But if you will try to understand once, you will get it. Definitely you will get it. Okay. So it's your homework now. You will have to check this closure property for all the operations. For all operations over whole numbers, okay, and for remaining two operations over integers. Okay, if there will be any doubt regarding these two, you can contact me over my number 78148 That's my WhatsApp number. You can WhatsApp me. If you still there will be any problem, you can call me, or the best will be you can message me over WhatsApp. Okay. So the last thing for today, we are going to do closure property over, okay, leave it. We will do closure property for rational number in our next video. But for today, you have to check closure property over rational, over integers, natural number and whole numbers. Thank you guys. I hope you will like it.